Today we are solving this problem, count some matrix with all ones. So basically we are given a matrix m cross n like this, and we have to find all the submatrix that are available. So sum of all of them. You can visualize like this. For example, this is the matrix given to us. Then we have to find how many total submatrix would be there. Right? This is what we have to do. So for example, this is also one submatrix. This also is submatrix. This also would be one of the submatrix. This also is submatrix. So many combinations would be there. Like in this case, we have total 13. So you can see every cell having 1 is itself also a submatrix of 1 cross 1. So we have to find the sum of all of them. This is what we have to do in this question. Okay. So what would be the approach basically here? So before going to approach, let us understand few things that we need for this. So for example, let's say this is our matrix, this is our array. Okay, now we create, if let's say suppose this is as of now these are the values 1 and 1. Suppose this is 2D 1D array only. So if we go for a DP, that how many subarrays are here? Submatrix, this guy and this guy at 0, only 1 possible, right? Yeah, so we can write here 1. Now let's say we have added this 1. Then how many new one added now? You can visualize like this. 1, this is already there, but after adding this, there is 1 combined both of them and 1 this guy itself, right? So total 2 would be coming there if we are adding something, right? So this would become basically total 2, but in DP it would go whatever is the value already sitting there, and after adding we got 2 more. So it would come here like 3, right? And now suppose I am adding 1 more. Let's say 1 more 1 I have added. So how many new after? So far it is 3, right? Till here we have stored here 3, right? We found that there would be total 3 submatrix. But if I am adding 1 more, how many now would be added? I am saying added, the new one added. So those new one added would be like one of them is this entire one because we added this new guy, right? And one of them is with this, and one of them is this guy itself, right? So total 3 is also now being added. So 3 plus this is already 3, and 3 plus 3, 6 would come in the DP array. So this is just a clarification. So now you guys can observe here that whenever we are adding something, okay, so for example, we added this one at index 2, right? So we can say j equal to 2 be added this guy, okay? So j equal to 2 be added, and we are starting at I equal to 0 for this, right? So I we can say 0. So how many, as soon as we added a new guy having value 1, how many new submatrix were produced? These were produced like whatever is the j value. So j minus I plus 1, right? You can observe it clearly. When we added this guy, new guy, we found 3 more new subarrays, right? So if we put this value, so it would be 2 minus 0 because I is 0. So 2j minus I plus 1, 2 minus 0 plus 1, right? So total 3 new one submatrix were added just by adding 1, right? So this formula we would be using in our solution. So we should not get confused that why this formula suddenly came to the picture. There is a reason behind it. So let's go for the problem now. Okay. So the problem could be something like this, right? This is a matrix given to us. Okay. Now what we will do is our approach would be, here we can visualize one thing. We can have a height variable. Okay. Why do we need it? Suppose this is a height variable of size, whatever is the column size, whatever number of the columns are there, that many heights we are taking here. That means size 1D array only. Now why do we need it? When we are coming to this row, right? So wherever we have 1, that means we are taking the vertical height as 1. For example, at this row, what will happen? What will the height of this? Height of this would be 2, right? Because there are 1 more 1 top of it. What will be the height of it? Height of it would be 1 only. Here it is 1, so height would be 2. Here height would be 1 only, right? But in case here, if we look at the heights, what would be the height? Because this guy is 0 itself. So we cannot make the sum of these two. This would be only possible when we have here also 1. So if let's say I am putting here the height of this row, what would be the height? This guy would be 0 because this itself is 0. So here it will come 0. Now come to this guy. This is 1 and top of it sum is 1. So this guy would be having the whatever is the previous height here plus this one, right? So this guy would be having height 2. Now this guy would be having height 3 because 3 consecutive values are there. Similarly, this guy would having 2, right? So I'm just giving a rough idea. Now you might have a question, why do we directly going for this height and what is the brain behind it? So we will come one by one for this. Okay, so what is the intuition behind it is we are starting from very first row. You are taking the whatever is the height of it. Okay, now we are one row by row. Whenever a new row is coming, obviously new submatrix would be added, and these submatrix would be in itself as well as combining with 2. For example, here when we were at very first, we were having this as a submatrix, this as a submatrix. When we came to this row, we found few new submatrix. This guy, whoever is the one value, that also is one submatrix, plus top of that we found this guy is also a submatrix. This is also a new submatrix once we combined these two rows, right? So with this idea, what we're gonna do is at every row we would be keep on storing the height of these cells, right? So we will keep and use of that. Now how do we use of that? So we can use this formula. Now I'm not making in sky this formula, definitely we will explain. So far remove this height part. We know that whenever we are adding something at j, right, and it is starting at I, then j minus I were the new matrix we found, right? We just explain in this example here, right? Whenever we added any value, it is becoming j minus I plus 1. These many new submatrix are being added. Now you guys can visualize here, this is just a building block of 1D array. Now you guys can visualize here this thing. See here, if let's say this was only 1D array, whenever we are adding any value at j, which is 1, so we were getting only j minus I. Now there is a case that what if the height is also given to us? So for example, if this was 1D array and whenever we are adding a new j, this is the one, only this part would be giving us, right? But if we have a height like this, then what we can do is, see this j minus I of the height 1, this j minus I of the height 2 also can be formed. But you can observe one more thing here, that this height might not be the same, right? This not necessarily be the same, right? Because here, see here the height would be 1 or 2 here. This is also 2, this is also 2. So we can have a histogram like this, right? So we can multiply it by height j. But here this height is 0. Okay, so let me write it for this particular example. Suppose we are at third row, then here the height would be 0 because this guy is 0, right? And here the height would be 2 because top of it the sum is 1. So we will write here 2. Similarly, the height here would be 3 and here 2. So let me write it down, 3 and 2, right? So now at every point, whenever we are encountering at a j, right? So at a j, we are making this j minus I. Now you would have a question that here I am using j minus I, but in this example, I was saying that this would be j minus I plus 1. Now you would have a question, why this? So definitely you should have this question and I will tell you why here j minus I. So this I is basically not the start point, but this I is the point where the height is smaller. Height is the left smaller. So for example, here when we are, let's say we are at this cell, let's say we are at this cell. So the height is 2, right? So what is the smaller height here? So if we come into the here, this height is 3. So this is not smaller. This height is 2. So this also not smaller, but this height is 0. Height means here. Okay. So this 0. So this I is here the index of the column, which is basically having the lesser height on the left side, first lesser height. Now again would be a question that why do it matter? Why do we need this lesser height stuff? So I'll tell you why do we need this is because when we make a legit array of the same height, at that time we would be needed. For example, here this is the 2 height. So this 2 height can be come till here to make a rectangle, you can say this yes, rectangle only, but we cannot go till here, because if we go till here, this height has a 0, so we cannot go. So only up to this location we can go. So in this case, this I is the index of this guy, so that is why I am taking it j minus I. Okay, so this I is basically the index of the height which is just smaller than this guy, right? So here the height was 2, this guy has height 3, so no problem. This guy has height 2, so no problem. But this guy has a smaller height, so we can make our rectangle only up to this guy. Okay, now why I'm multiplying with this height j? Why not only j minus I? Because j minus I would be the valid when we had only the 1D array. So you can visualize like this. We would have, once we are adding this guy, we would have j minus I of the height 1. Similarly, we would have the j minus I submatrix of the height 2, right? And we know that whatever number of height is there, that many times it would be multiplied. So that is why what we are doing here is, first we are getting j minus I is the index of the smaller height on the left side. So that is why we are doing j minus I and height times. Because why height times? Because we are starting with height equal to 1, then we have height equal to 2, height equal to 3, whatever is the maximum value in this height, like up to 2 here. Okay, so we can have it some matrix of this after adding. So height 1, similarly of height 2, similarly of whatever up to height this guy we can go. So that is why we are using this formula. Now this thing for every row we can do. This generic example I took, that is why I picked a random row. Now this can be done starting from row equal to 0 till end. Okay, so in this way the sum of everywhere would be giving us the total sum of all the submatrix possible. Okay, now one thing here is, how can we find this height for everything, right? For this example, anyway we found that here the height is lesser. So to find the lesser heights, we can have the monotonic stacks. So monotonic stacks are required for the to get the left smaller or the left bigger values. So in our case, we want to get the left smaller values. So we will take one example, that what does it monotonic stack means. Okay, so for example, we can take this example itself, 0 2 3 2. Okay, so what would be the left smaller height for 0th row? For this guy, 0th column, sorry. So left smaller height is, there is nothing on the left side, so we can mention it that this would be -1, for example. So there is nothing. So if stack is empty, that means it would be there is nothing on left side, so we can take it -1. Now we are coming to this guy. So what is the height here? Height here is 2. So left smaller would be what? Left smaller would be whatever is the there and the left side. So index 0. Right, so 0 index would be the left smaller for it, because height here is 0. Okay, now similarly when we will come, I'm taking the indexes here. When we are coming to here, what would be the left smaller height? It would be the index, this guy, index of 1. So here it would be 1. Similarly, we are coming to here, what would be the left smaller height? Left smaller height for this guy would be this 0th one. Okay, so this I have shown in terms of this array. Now same things we can manage using a monotonic stack. So whenever a greater value is coming on the left side, we would be removing that, and we will keep on only the smaller values on the top of a stack. Okay, so let's look at the code part of it, which would make a better sense. So see here, first of all what we are getting the row and column values in the matrix. Now we have created this heights 1D array of the size column. You can see here we created this height of the size column. We have total 4 columns. So 4 size height variable we have created. Okay, now this is our answer variable total, where we would be parking. So see here what we are doing. We are using the for loop here, I equal to 0 row and columns, and then we are checking that heights j is equal to, if anywhere mat of ij equal to 0, then we are directly putting it 0. For example, here when we came here, we directly put it 0 in the height variable. So see here mat has 0, in that case we are directly putting it 0. Doesn't matter what is there on the top of it, because this cannot be the base of any one. That is why it is 0 only. So that is why we have put it here 0. So if it is mat itself is 0, then we are putting height equals 0. Otherwise, whatever is the height in the previous row of that column plus 1, because in that case this guy would be having value 1, because in matrix we have only 0 and 1. So in this case we are increasing. You can visualize it like when we encountered here, we added the previous values in the height. So we are taking single height row for every entire solution. We are not taking the entire 2D array. Okay, so previous values can be accommodated. So that is why we are doing this. So now we would be having height at every row, right? So I equal to 0 to every row we are going. So for example, I equal to 0, we got this height array. Now what we are doing, we have written a method which will count that how many count from histogram. This method we have written, which is taking the heights array as the input. Now we will see it, how it is working. So see here, we are passing the height array. So we are, first of all, we are taking the length of it. Now we are creating this stack. Okay, this is simple stack, nothing special. We call it monotonic because we are keeping whoever is the smaller on left side. Okay, and then we are creating a DP array to park the values. Okay, now you can see here that we are starting for j equal to 0 to whatever is the length of this height. We are taking here. You can see here, if stack is not empty, okay, and the peak value is greater than the whatever is the current height of this j. In that case, what we are doing? In that case, we are popping it out. Why we are popping out? Because we are keeping on the stack only the smaller values. Okay, so for the sake of smaller values, we are popping it out till the time this peak is greater, because our task is to keep only the smallest value on the left side. Now once we have popped out, what we are doing, if stack is empty, that means there is nothing smaller on the left side. For example, when we were here on very first row, the height itself is 0 and left side is nothing there. At that time our stack itself would be empty. So that is why we are taking here. If it is empty, that means what we are doing here is dpj would be the whatever is the height of it, and j plus 1, because at the j it is starting from 0 till j. So total length would be j minus 0 plus 1, right? So anyway, this would be j plus 1. But in the case if it is not empty, that means we have a left smaller legit value. For example, when we were here, for example, when we were at here 2, then at index 0 we have a left smaller values. Okay, so in that case what will happen is we are taking this value. So whatever is the previous index, this previous index is basically the index of that left smaller value, because we are taking from the peak of this monotonic stack. So this pre-index would be the index of that left side value which has having the smaller height. Okay, so now what we are in, whatever value we have calculated, you can visualize it here like this. See here, we filled this table, that whatever we found on the left side, okay, plus whatever on adding we found. Okay, so that is why 2, when we added this one, we found 2 more new. So 2 more new plus whatever is the previous values. Same way we are doing here. That dp is equal to dp of previous index plus height into j minus previous index. Same thing we did here. Okay, so same thing we did here like this. So j minus I into whatever is the height of j, right? So same thing I am doing here. And we are keep on adding into the dpj, right? dpj is equal to dp of previous index and heights, because we are summing all of them, that at this index how many would be added new. Now once we are done with this, we are adding them into the resultant value. Okay, so whatever value we have updated, we are adding that into the result, and we are pushing this j index into the stack, because when we further go to right side, this also might be a potential left side monotonic stack top, because we need the smaller value further when we go to right side. Okay, So in this way we would returning the total resultant submatrix for the given heights that we provided. Okay, so now we will provide the heights of every row, right? Heights of every row. So see here, first of all we did here, you can see here we found the heights, and right after finding the heights we are calling this function. Okay, for every row we are starting I equal to 0 till all the rows, and every row we will having the heights variable array, and then we are passing it. So we are taking the total into it, and finally once we are done for this entire rows we would be having this total into it. So let me execute this code. So I am running this code, and let me try to submit it. So what would be the time complexity here? The time complexity here is like O of m into n, where m and n are the dimension of this matrix, because we are not taking other than that we are taking that O of m into n, and we are taking the extra space of O of n. So this is how we can solve this problem. So thank you for watching this video, and if you guys have any concern, please make a comment over there. Thank you.